Welcome everyone to the latest edition of the Net Zero Festival, brought to you by the installer. And today we're talking about all things rainwater harvesting. And we've got a number of experts here to do that with. We have Geoff Ball, who is the Specification Manager at Wilo. We have Lutz Johnen, Chairman at the UK Rainwater Management Association, and Thom, who is an independent environmentalist, a sustainability consultant, and really looking forward to this conversation. So I'm going to hand over to Geoff to run us through a few points from Wilo, and then we're going to open up to some questions and have a bit of a discussion around this. Okay, thanks, Geoff.
Excellent, thanks very much. So yes, my name's Geoff. I'm going to talk through some facts and figures and some interesting information on the harvesting topic from a manufacturer's perspective. So I produced a small presentation. Hopefully that will give us some interesting insights. So as we fast approach a net zero carbon design ideal for our buildings and our designs, let's talk about rainwater. Rainwater for life. You know, we need fresh water for our daily lives, for producing food and industrial goods, and for drinking, you know, to basically sustain life as we know it. So when we consider that nearly 1/4 of the world population doesn't have access to clean drinking water, that's a frightening statistic, really, and it's something that perhaps in certain circumstances rainwater harvesting can link into. So Wilo has identified, as part of its long-term commercial strategy, water shortage is one of 6 megatrends that are really going to affect people's lives throughout the next few decades. And as resources become scarce, water being a prime example of this, we think that rainwater harvesting can go some way to help alleviate that in a lot of circumstances. So probably best to begin by defining what is rainwater harvesting. Well, as we know it, it's the accumulation and deposition of rainwater for reuse on site rather than allowing it to run off via gullies, drains, or pipework of other descriptions. From a domestic perspective, rainwater is generally collected from building rooftops, be those houses, garages, sheds, etc. And really, the sensible utilisation of rainwater with specifically designed systems can be inexpensive and really, essentially, very, very good for the environment. So I suppose we've identified what it is now. When and where can we use it? So harvested rainwater can be used for non-potable, i.e. non-drinking standard purposes such as toilet flushing, washing machines, irrigation, garden watering, cleaning the car, or for some industrial cooling applications. So from a free resource, essentially, there's an awful lot of applications that we could put this to with very little effort. However, it's worth noting that untreated rainwater is certainly not suitable for use where drinking quality water is required, such as bathing, showering, dishwashing, or drinking for that matter. There are a number of tasks that we can go through and equipment that can be used to make rainwater filtered and fit for human consumption. However, in most cases, this tends to be very commercially undesirable, as the cost to actually provide the amount of filtration and cleaning required for rainwater just doesn't make it viable in most cases. So when we talk around rainwater, we really need to consider some of the environmental aspects to this. And one of those is that our water supply in the UK is under strain. Climate change is driving the need for innovative solutions for surface water management for sure. The annual UK temperatures are predicted to rise somewhere between 2 and 3.5 degrees by the 2080s. Seasonal distribution of rainfall is predicted to change significantly, with the possibilities of winters becoming wetter, something that I'm sure we're not looking forward to at all. Sea levels, predicted to rise up to anywhere like 600 millimetres, and there's an expected increase in the prevalence of extreme weather events. All these things brought about by changes in our environment. So we talked about the water supply being under strain. It's worth noting that the average person in England and Wales uses approximately 130 litres of water per day. So consider that as, 130 large bottles of pop. That's quite a considerable amount. Most of that is used for washing, toilet flushing, but it also includes, for drinking, cooking, car washing, and watering the garden. So if we think about some of those different applications, think about what we just said before. How many applications of those could we use rainwater for? I think you find there's quite a lot. Statistics from Ofwat showed us that we consume almost 50% more water than we did 25 years ago. And again, that's a lot as households increase. The technology that we incorporate within our daily lives also uses far more water than it did in previous generations. So let's think about that 130 litres of water demand per person per day. How could we perhaps use that a little more responsibly? So by utilising rainwater in some of these instances, we could save up to 71 litres of drinking water per person per day. So it's over half of the average water demand per person. With the increasing cost for water, all the stormwater runoff and the cost of water authorities treating all that potable water that's flushed away down the drains, it's becoming more and more worthwhile to utilise rainwater as and where we can. So if we see on the right-hand side, this chart shows a typical household's water usage per day. So we can see the two largest chunks in blue and dark green. So showering, bathing, washing, etc. consumes 47 litres out of that 130. So that's a huge chunk. Toilet flushing, even with dual flushing toilets or more economical toilet designs, that's still 42 litres. That's still a heck of a lot. Washing dishes, laundry, etc. comprises the next biggest chunk. And then drinking and cooking, a relatively small amount. So out of those, there's a large number of those that we could potentially use rainwater to supplement the potable water. So again, from a manufacturer's perspective, this is where we think that technology can play a real part in that innovative use of rainwater for domestic, commercial and industrial applications. As it's a free resource, it doesn't cost anything to actually harvest it. It's the only cost really comes in when we actually try to utilize it and store it and then put it to use within an application. So here we have in this example a typical domestic family type rainwater harvesting setup. So we can see that water's collected from the roof of the family house. It's channeled via the guttering in through a section of mechanical filters into a large or small storage tank. Now this is where the rainwater is going to be collected, ready for use. The storage tanks can be in a variety of sizes and shapes to fit, the size and shape of the garden or family environment. So once the water's been stored, we need to figure out how we can actually use it. So Wilo, being a pump manufacturer, we would suggest in this instance a pumped application provides the best way to get that water from the tank in to the house or the garden application. So here we see that the water stored within the pump, or within the tank, and within the tank is a float switch. Now that float switch serves a number of purposes. Over on the left-hand side, we can see in this instance we have a self-priming pump. So that's a pump that will basically suck the water up from inside the tank and then pump it out and distribute it to wherever it's required. One of the important parts of this is the automatic kit or the solenoid valve assembly for potable water replenishment. So we mentioned the float switch. When the water within the harvested rainwater tank drops below a certain level, that float switch will energize the solenoid valve, which will basically allow fresh mains potable water to enter the tank and refill it. This basically not only provides continuous use, but it also means that it protects the pump itself from running dry and protects the longevity of the component. So with a small number of individual components, here we have the pump with its pressure sensor on the discharge line, which senses changes in pressure. So essentially when an application opens, someone turns on a tap or starts the garden hose, that will cause a pressure drop within the line, and that will cause the pump to activate. The pump will send water along to the application until it's no longer required. So here we have a different installation example, again for domestic type use, but this is a tank mounted submersible pump located within the actual storage tank itself. Certainly for space saving aspects, this is a very simple and easy type application to install. The waterproof submersible pump sits within the tank, again controlled by the float switch, and that will basically draw water from the base of the tank, push it out through the discharge line of the tank and through, again, a pressure device or flow monitoring device, which will tell the pump when to start and stop. Again, we have a solenoid valve in order to provide fresh water top up for the stored water tank. And again, a slightly different arrangement using one of the Wilo domestic rain system units, which is a slightly more all-encompassing, slightly more sophisticated unit. Again, using a self-priming pump with a controller built into the unit itself, which can be mounted in a garage, in a loft, or somewhere where unobtrusive, where the unit could be stored within the building, a house or garage, etc. Again, self-priming pump draws water up out of the tank and distributes it within the family home. It's worth noting that other than the basic components of the solenoid valve, the pump, and the tank, float switch, there are a number of mechanical filters that we would suggest are installed just to make sure that any debris that's washed down from the roof and the guttering is pre-filtered out before the water hits the storage tank. And again, in some instances, depending on the size and shape of the tank, perhaps a filter between the tank and the pump unit, again, just to remove any small amounts of sediment or debris that's collected at the bottom of the tank. But all in all these different types of systems provide one way of utilising stored rainwater, again, which I mentioned before, a free resource, in order to reduce that demand and that consumption of a typical household and become a more sustainable and a more energy efficient domestic dwelling. We can see here a typical checklist. It's recommended that most of the components are checked relatively frequently, if not monthly, then certainly quarterly, just to make sure that any filters or seals, etc., are working properly and not clogged or inefficiently working. So harvesting rainwater, in principle, it sounds like a great idea. In practice, there are only a small number of components potentially that we have to use in order to get a system up and running. And it's governed by a number of regulations and standards. A number of these include in the National Planning Policy, Sustainable Development and Climate Change, PPS, flood risk, the building regulations and standards, particularly Part H for rainwater drainage, British Standard BS 8515, which now includes BS EN 16941, which was updated in 2018, and BS EN 13077, which covers devices to make sure that there's no backflow of utilised rainwater into the mains water system. But through good planning and good application and installation, utilisation of the regulations and standards, we can really start to eat into that potable water usage and create a more sustainable environment for domestic and commercial dwellings all around the country.
To open the floor to Robin and Lutz, and thanks very much, Geoff, for that presentation. So could you guys sort of sum up or really give us some focus around the key benefits of rainwater harvesting? Sort of where's the biggest potential with this? Maybe Lutz, would you start us off?
Yeah, I mean, I can probably there are two things to this. Like Geoff already pointed out, there's the aspects are potable water consumption reduction, and the other one is flood prevention. In other European countries, rainwater harvesting is almost mandatory. In Belgium, for example, for flood prevention. Because if you can imagine, if we're using all the rainwater, if every building would use the rainwater instead of having it go to a sewer, the amount of water hitting the sewer is going to be much less. And that's why certain countries have made it mandatory to have everyone use it, because then, of course, if one building out of 100 only uses it, it doesn't have an effect. But of course, if every building does use it, it has a massive effect. So new developments have to have rainwater harvesting. And then, of course, as already pointed out, you can, of course, use the water for toilet flushing, washing machine. It's free water falling on your head. It's soft water, so it has a very good, in terms of washing machine, it's no scaling in the washing machine. Those elements are side effects, less detergent you need to wash the clothes. In the irrigation, plants love rainwater. Rainwater is the best water to irrigate your plants with. It's not already soaked up with minerals or the drinking water. So literally a plant irrigated with rainwater will grow better than a plant irrigated with mains water. So these are just side effects that you're really getting out of using rainwater.
And I live in a coastal town here in the UK, and surface against sewage are all part of it as well, because actually the sort of storm overflows lead to these CSOs spilling sort of sewage into the sea as well. And so actually, if everyone was sort of harvesting their rainwater a bit better in the local community, that would obviously reduce that as well, wouldn't it?
Correct.
So we've sort of talked a bit about what it can be used for, but Robin, maybe or Geoff, where can it be installed? Can anyone install this? Do you need to be in the house? What's the?
I mean, ideally, you would want a professional installer to, as you would with most type plumbing applications. Somebody that knows what they're doing in order to install a pump system. Depending on the size and scale of the property and the size and scale of the installation, you might want to dig a hole in the garden and put a 500-litre tank, or in its simplest form, rainwater harvesting can be as easy as putting a water butt on the bottom of your downpipe and using it for garden irrigation. That could be done by anybody. These types of things are available from hundreds of outlets across the country. Most garden or DIY stores can give you a kit to tap into your downpipe, and then you could use whatever size vessel that you want or that you can accommodate. And all Libin would do at a push.
Yeah. Okay, great. Thanks. Robin, do you want to? Robin, I think you're on mute. So I'll sorry about that. But just start again from now, yeah.
Yeah, the commercial application of rainwater harvesting is probably the most economically beneficial to the person paying for it. But with with residential, there are carrots and sticks already in place. So let's talk about the carrots first. It's always worthwhile. So for new build developments, we're finding that some local water supply companies will provide a cashback or a reduction in their connection fees of up to £500 for introducing water efficient systems. So I've had one developer come up to me say, I'm interested in using a rainwater harvesting system to help reduce my total internal water consumption, and that's enabled them to save up to £500 per plot. So that's, there's a cash incentive there. So there's a good carrot that's hanging around with certain water connection companies. But then there's also, a bit of a stick. Certain local authorities are already asking us to reduce our internal water use by up to 10%. And that invariably means we need to consider what we're doing with our internal water usage in general, but also planning for things like rainwater. I love to see, like you said, all sorts of applications for rainwater harvesting, from water butts down to stored systems. And having been, seen firsthand the impact of flooding twice in the last 20 years of my parents' home, it's something that, I'm acutely aware of as an environmentalist, that we need to try and store this water before it goes off. And the application of that is most likely rainwater harvesting in some way, shape or form.
Mm-hmm. Mm-hmm. So is this something that's going to become, do you think, given that sort of sustainability and climate change agenda, something that we're going to see that's becoming a lot more common, a big topic of interest?
Very much so. It was one of the only things kept in as part of the housing review back in 2012. And along with the energy efficiency standards, water efficiency was highlighted as one of the major elements to keep from what was the old code, the Code for Sustainable Homes. So this standard that we've kind of kept in the background, which has been helping to inform our Part G, our internal water use requirements under the building regulations. And I'm sure Lutz will be able to add some more information from one of the major associations around rainwater, how that's kind of helping to shape where we're pushing, especially with the influx of what Europeans are doing and what other countries around the world are doing to help improve the use of our rainwater.
Yeah, no, there's definitely a lot of movement on this at the moment. You might have followed the Environment Agency's presentation last year, where the chairman gave a speech about all the water companies were handing in their 5-year plans, and first time in history, all of them showed the jaws of death, meaning they're running out of supply in increasing demand. Yeah, so it opens up the problem of having to cover all the demand. The demand is rising and the supply is going down because of the change in climate change elements. So that was the first time in history where literally even utilities up in the north, United Utilities and people were having the same reporting the same issues as Thames Water, who always been reporting this already, because there's the prediction by 2050 we'll be running out of I think it was 4,000 megaliter a day in the UK. That's 4 million liters of water. So Thames Water alone is looking at a deficit of 450 million liters a day. So the water companies are currently looking into how they're going to cover the gap. And that's why, for example, this connection charger, what Robin was referring to, is one of these tools to now incentivize people to do more about water efficiency, because unfortunately, we're all money driven. So the point is, if you don't do anything saying, let's be nice and green, unfortunately, it doesn't really move things ahead. So that's why currently, as chairman, we're involved as the association with a couple of, authorities, GLA, kind of talking to to people that are looking into ideas of policies to put into place to push more for these kind of things. And then, of course, rainwater harvesting is part of a whole array of water efficiency devices and things like that. So, yeah, I think we're going to see more coming, because we think we're surrounded in water and it's raining all the time, but unfortunately, that's not the case. I mean, yes, we are surrounded. Yes, we are surrounded with water, but I'm talking about that we think we have plenty of water around us. In terms of availability.
It's quite hard to get people to sort of get their mindset in the right place, isn't it? Sometimes for this, but if I ask you each for your, if you had one wish, also one thing for people listening to this to take away, something practical that they can do about it. What would that be? Give you guys a moment to think about that. How about you, Robin? Do you have something that people, whether they're an installer listening to this, just a homeowner, any individual, what is it that they would have to, what can they do?
I think being prepared and being aware, being educated about this. I mean, the people watching this, I think, we're really fortunate that, the ones that are watching this are the open-minded individuals that are going to carry on this education forward to their clients and their friends, their family, to implement reduced water usage in houses and at home and at work. I think trying to just use less is always, the emphasis to begin with. And designing in systems for rainwater harvesting when there's feasibility for it, when we can plan for it properly, when we can design it in the right system at the right point for the right, for the right process. I'm a big fan of just using less. So, a little 30 seconds less in the shower every day is always worthwhile. So that's the easy one that anyone can do.
Great. Thanks, Rob. Lutz?
I think, from a practical point of view, it's as a plumber, every time you get into a home, look for the opportunity. Yeah, because, one home might be just doing the refurbishment, so you can, use rainwater harvesting for toilets and things. But if not, the garden, 50% of all systems being installed in Germany are garden irrigation systems. It's very easy to put a hole in the ground and divert the water into a tank, and then use one for example, of the Wilo submersible pumps to supply, your garden. If it's, of course, sufficient, you don't want, you have to have a sizable or a garden where it's worthwhile. But this is the opportunity you want to talk about. Like Robin is saying, it's the education element. Every time you come in, have you considered this? And then you can get into a discussion to see what is the best system to potentially put in, to make it worthwhile. But it's really like talking about it.
Brilliant. Thanks. Yeah, talking about it, education. And Geoff, any sort of final thoughts, final messages to leave people with?
Yeah, sure. I think, again, about education and, spreading the wider word that this can be really, really beneficial. It's sadly often one of the first things within a commercial project that tends to be value engineered out. People look at how cheaply they can get their BREEAM points and they think, okay, or I'll put some PV in, or I'll do this, that, and the other. And yeah, great, I've ticked all my boxes and I've built my building and walk away. But I think people need to think about the wider effect of, is this the best, most sustainable, most environmentally friendly building I can build? And do that, rather than thinking, is this the building that somebody wants, but I've done it, in a way that's maybe not as sustainable. Let's think for future generations. Is that building going to work today? Yes, of course it will. Is it going to work 5, 10, 15 years down the line when, demand is increasing exponentially for water resources? Maybe not. So putting plans into place now and making sure that we're taking, the moral high ground and the, the right course of action to make sure that, future generations reap benefits.
It's a scary thought, that jaws of death there was from Lutz as well, wasn't it? I'll leave everyone with that. I just want to thank you guys immensely for coming on here today to talk about this. Thanks so much, Geoff, for your presentation, and Wilo. Thank you, Lutz. Thanks, Robin. Pleasure. And thank you for listening as well. We hope you've really enjoyed our virtual festival as we're helping to move towards net zero, and hopefully join some of our other conversations again soon. Bye-bye. Bye-bye for now.
Bye-bye.
Thanks. Cheers. Thank you.